Hello, IG2 Extended Math students. We're going to go over the Probability Formative, Chapter 10. It does include some questions on statistics. So statistics and probability go together. That's why they're in the same chapter. Question number 1. We're going to do a tree diagram here. Remembering that at each branch of the tree, the probability is going to add up to 1. So we're going to do the first branch here. The probability that it rains on Monday is 3 over 5. Get the total to 1. We need 2 over 5 that it doesn't rain. Notice that we write the outcomes at the end of the branch and the probabilities besides the branch. That's what the syllabus asks us to do. If it rains on Monday, so I'm going through the upper branch. If it rains on Monday, it rains on Tuesday. 4 out of 7, 3 out of 7. Total is 1 again. And if it doesn't rain on Monday, it's a different probability. It's more likely to rain on Tuesday. So I have to put 5 over 7 in that branch. And then below that is 2 over 7. Total is 1. Okay, the probability that it rains on both days. That means it rains Monday and it rains on Tuesday. 4 out of 7. So probability of rain on both days, we have to multiply our probabilities. So rain, it's 3 out of 5, 3 over 5, times 4 over 7. No miracles here, 12 over 35. I can't simplify that. I could express it as a decimal number. I'd have to round it probably to get it to 3 significant figures. It does recur because it's a fraction, but I like fractions. I'm gonna do my answers in fractions. Rains on Monday, but not on Tuesday. So again, I'm going up here, down here. So that's 3 over 5 times 3 over 7. Probability Rn, if I want to write it that way, or R and end. So I said 9 over 35. I didn't say it, but I mentioned that we're going to multiply those 2 branches. And it only rains on one of the 2 days. So I've got the probability of Rn. I'm going to have to add the probability that it doesn't rain on Monday, but it does rain on Tuesday. That's NR. So the OR word means add. Okay, so I got Rn, let's do NR. So that's down on Monday and up on Tuesday. That's 10 over 35. Add 10 over 35 plus 9 over 35, and I get my answer 19 over 35. So this means add, and up above there means multiply probabilities. All right, and then finally, we got Wednesday. The probability that it does not rain on Wednesday, after it doesn't rain on Monday or Tuesday, and Tuesday, sorry, I used the word and. Okay, so I'm going down all the branches to add a 3rd branch for Wednesday. So new branch of the tree here. and it's a no rain situation, so that's a 1/4 for no rain. Okay. Now the question says, calculate the probability that it rains at least one of the 3 days. Alright, so I'm going to use the idea that I could add some more trees up above here. Understanding the probabilities might be different, but the total of all these numbers up here is going to be, when I add it to the 1/4 at the bottom, the total of all these probabilities has got to add up to. That means that I could subtract the probabilities at the bottom from 1 to get the rest in between here. Okay, that's the question. If it rains on Monday, but it doesn't rain on Tuesday, etc., etc., I have to go through all those other probabilities that it does rain on one or more of the 3 days. So I'm just going to subtract the probability that it doesn't rain on any of the 3 days, and I'll have my answer. So just do 2/5 times 2/7 times 1/4, and I believe I get 4/140. So that 4/140 is going to be subtracted from 1. Okay? And 1 is 140/140. So that leaves me 136/140. I can reduce that. Divide by 4, and I get, again, I'm not teaching fractions here, I'm teaching probability, 34/35 in lowest terms. Equivalent answers are acceptable. Alright, I saw the next question actually earlier, but we're going to actually answer it now. Katrina plants some flowers, or plants that produce flowers. And if there is a flower, it can only be red, yellow, or orange. So let's make a tree diagram, which is what's requested, for this situation. Again, I make my tree, I write the probabilities beside it, and the outcomes at the end. So the two probabilities or outcomes are flower or no flower. And we have the probabilities written there for us, 7 out of 10. So the not probability must be 3 out of 10 to make it add up. Okay, now we're going to say if there is a flower, when there is a flower, we're going to have another branch to this tree. So do that situation here. But again, we have 3 outcomes on these branches. We have red, yellow, or orange. So if it's red, it's 2 out of 3. If it's yellow, I need to write my outcomes here. Red, yellow, and I don't have a color for orange. And we'll make it orange. Looks like green to me. Alright, so those are the 3 outcomes. Yellow is 1 out of 4. Okay, so do a little bit of fractions again. Common denominator 12, 8 out of 12 plus 3 out of 12 is 11 out of 12. That leaves me 1/12. Okay, in the last branch to complete the diagram and get my 5 points. Okay, a plant is chosen at random. Find out the probability that it will not produce a yellow flower. So it's the not situation again. Subtract the probability of a yellow flower. Okay, so yellow means that it flowered and it was yellow. So that's 1 minus 7 over 10 times 1 over 4. Okay, and that's 7 over 40. So the probability that it does not produce a yellow flower is 33 out of 40. Again, you can say 0.825 if you wish, 0.825 if you wish. That's acceptable answer. Katrina plants 120 plants in her garden. How many orange flowers would she expect? What's the probability of orange? Okay, it's got a flower and it has to be orange. 7 over 10 times 1 over 12, that's 7 over 120. So basically I can take the probability, 7 over 120, and I multiply it times 120. You can see it was 7. It was 7. That's called the expected frequency. You multiply the probability times the total. All right, next question. 1. Okay, so when it adds up to, we got a little table here. And the totals have to add up simply. So for a small international school, that's 255 students. Complete the table. How many are from Asia? 62 plus 28, 90. From Europe, I would say 80. And then I can do 255 minus 170, and I get the total Africans. Subtract 85 minus 17, 68. Now I can add up my columns, and I get totals. 165 plus 90 equals 255. Table is complete. What is the probability that a student chosen at random is a girl, given she's a girl, that's 90 girls, is going on holiday to Europe? So Europe, here. Okay, so this is the outcome, favorable outcomes, 45. And again, it's a student chosen at random. It doesn't say a girl chosen at random. So I didn't really need to look at that girl. So I'm looking at the total, 255. So that answer is just 45 over 255. Simplify the fraction, 9 over 51. Question 4, statistics. Okay, so we're going to be looking at a frequency table here with some time intervals, and we're going to have to answer some questions. In which interval is the median time? So 150 students, I can do the n plus 1 over 2 formula. So that's 151 divided by 2 is like 75 and a half. So where is the 75 and a half student, or in other words, the 75th and the 76th student? So add these up, 21, 40, 77. So all of them, excuse me, both the 75th and the 76th student are located in that 45 to 55 time interval. So I could have just taken half of 150 with this many students, and I'm okay. So 45 to 55. Using the mid-interval values, 10, 27.5, etc., calculate an estimate of the mean time. So again, this is group data. I don't know the exact times of the first 6 students or the next 15. So I'm just going to have to assume that each of them is at the midpoint and that they'll average out okay. So it's an approximation, it's an estimate of the mean time. Okay, so first interval, midpoint 10, frequency 6, add, midpoint of the next interval, they give it to you, 27.5, divided, or excuse me, times the frequency, 15, add, 40, next midpoint, add the two ends, divide by 2, 19, add 50, times 37, now 55 plus 70 divided by 2. That's 125 divided by 2 is 62.5. A little harder midpoint there. Times, sorry, I was ready to divide already, 53. Add the last one, 75 times 20. I think that's 1,500. And then divide all of these by the total frequency, 150. So I get a total of 7,895 divided by 150. And the approximate mean is 52.633333 recurring. That's not approximate, that's exact. Well, again, it's approximate because we had the midpoint situation. So I'm just going to round it to 52.6 minutes. Our units are already given for us. Complete the cumulative frequencies. So you can notice that the inequality signs have been simplified to just less than or equal to. So you can see in the first interval, that's good, 6. Now, how many were under 35? You have to add the first 2 frequencies. 6 plus 15, 21. Oh, it's done for us. And then 21 plus 19 in the next interval, 40, plus the next one, 77, plus the next one, 130, plus the next one, 150. Got to my total. 150 are less than or equal to 80 minutes. So that works for us. Fill in all those values. Cumulative. Add all the frequencies up to that point. Do a graph, okay, and we got to pay attention to the scale here. Use 1 centimeter equals 5 minutes on the horizontal axis, and 1 centimeter represents 10 students up to 150 on the vertical axis. And these values for x and y are given in the table. Time is on the horizontal axis, so that's x. And our students are going to be y. Okay, do your scales here. Again, the x-axis is 10, 20, 30, 40, 50, 60, 70, 80 minutes. And then we do our students by 10s on the vertical axis. Okay, so I get my axes done. I labeled them with the units, and I put a title on the top of my graph, homework time, following the directions they gave for the scale. I know you guys can do it a little bit neater than this. And now we're going to need that data from the previous table to plot x and y on here. Alright, well here are our points. X was 20, Y was 6, X was 35, Y was 21. Again, we got to pay a little bit of attention to the scales here. 2 per division vertically, and then horizontally it's just 1 per division, 1 minute per division. Got all my points plotted here. Now I need to make the ogive, the shape of a cumulative frequency graph. Nice S-curve. So again, there were 0 students that did it and did 0 homework. I don't know how that is, but I guess that's the case. Very good class or school. And then I'm going to go all the way up here and try and get that S shape with a little bit of difficulty. Best I can do. Alright, so now how do I answer the questions for this distribution? The median time, that's the middle person. Okay, how long did the middle person of 150 take to do their homework? So I think that would be 75 for the middle person. Or again, we could say 75 and a half if we wanted to be more exact, but I can't be that exact on this graph. So I'm going to go across 75 here and come down to the x-axis, and I would say that my median time for the middle student out of these 150 students is 55. Okay. Next question was the interquartile range. Okay, so median time is like the second quartile. So we said that was 55 minutes. All right, so I need to know the 1/4, the 25th percentile, and subtract that from the 75th percentile. So 25% of 150. Is 37 and a half. Difficult numbers. Then 3/4 again of 150. About 117 or so. So not the best numbers to work with because I'm taking quarters of 150. I was figuring out 140 before. Didn't really much affect my answers. So I got to go across from 1/4 of 150, 37 and a half. And I have to go across from, again, the number I had before was 112 and a half, I think, for 3/4. Alright, so I'm going to use 37 and a half, a little bit higher, sorry. Come down there and I get about 45, 46 for Q1 for the time, okay? And then go up and look at the 112 and a half cumulative frequency, and I get about 65. So my interquartile range, again, the answer is in time, not in people. I want to know the difference between 65 and 45. Okay. I get 20. Okay. I said 46. (65 minus 46), 19 minutes for the interquartile time. Okay, the number of students who are between 50 and 60, I have to look at my x-axis in this case and go up and see what the cumulative frequency was for 50, looks like 58. Cumulative frequency for 60, a little bit higher. 92. So 92 minus 58. I got a little bit higher answer on the mark scheme. Did I look at 60 correctly? I believe I did. So maybe my curve didn't go up quite as much as I wanted it to do. Might lose a point on this one. So anyway, I wanted to go in with the time of 60 minutes and the time of 50 minutes and find a corresponding cumulative frequency. 92 minus 58, 32 for my answer. The probability as a fraction of a student around took longer than 50 minutes. So how many took under 50 minutes? Well, I just said it, 58. So now just subtract 58 from 150, and I think I get 92. So again, 92 probability. How many students were there? 150. So again, you can simplify that fraction if you wish. 46 over 75. I can't do much better than that. Probability of a fraction that 2 students chosen at random took longer than 50 minutes. Again, this is an older exam. We're not replacing students here when we do this calculation, so I think it's actually 46 over 75 times, reduce the numerator and denominator without replacement, it's called. 45 over 74, so that's an and. 2 students were chosen at random and both took less than 50 minutes. Big numbers there in the numerator and denominator. I'll let you crank those out. All right, so we are now looking at Sasha, who's walking or cycling to work. So we learned earlier that the probability can help us find frequency, estimated frequency. So Sasha's riding 3 out of 5 days. Multiply that times 55 days, and you get the expected frequency for riding her bike. He or she, I don't know, Sasha, I guess it's with a C, I don't know which that means. 33 days. Walks to school, sorry. Walks to school 33 days. Okay. The other 2 out of 5 days, Sasha is cycling to school. Calculated that probability that Sasha walks to school in the first 5 days of the term. So again, I'm going to use that walking probability for 5 days. Each and every day, 5 times. So 3 times 5 times 3 times 5 times 3 times 5 times 3 times 5. I'm just going to use exponents here. 3 to the 5th, I think, is 243. And the denominator is 5 to the 5th, 3125, 3,125. You can give this as a fraction, as a decimal. Actually no, it's exactly 0.7776. You may round that to 0.778 if you wish. Okay. Exactly. All right, next. We're going to look at a tree diagram for Sasha here. If Sasha walks to school late 1 out of 4 times, so not late must be 3 out of 4 times. And again, the walking, cycling distribution And then I can carry down the, well, we better pay attention. If he, now I know, I should have read that earlier, if he cycles to school, the probability that he is late is 1 out of 8. 1 out of 8. Basically every 4 weeks he's late. And then make it add up to 1. 7 out of 8. Calculate the probability that Sasha cycles to school and is late. So again, you're going down to cycle, that's 2 out of 5. 2 days every 5 days. And then and is late, so that's times the late probability, which we were given. 2 out of 40, 1 out of 20, 0.05 if you wish. 0.05. Calculate the probability that Sasha is late to school. So this is cycles and late. We have to look at walking and late also. So I'm going to add 1 over 20 plus the or that Sasha walks to school and is late. 3 over 5 times 3 over 4. Oh, the denominator is nice and friendly. So I get 9 plus I'm sorry, it was 1 out of 4 was late. I thought I was getting a ridiculous answer because Sasha was going to be late half the time. Not too good, Sasha. 1 over 20 plus 4 over 20. That's 3 over 20, sorry. That's 4 over 20. 1 out of 5 times. Not too good, Sasha. 1 day a week you're late.